Hello, my name is Jayesh Rajput and my group mate is Shivam Saptasagre. We will be presenting you the home automation project that we have implemented, and we will also show you the demo. So this PPT presentation is regarding our Emertxe internship program. Uh, okay, so we will see what we have learned through this internship program and our project. So first of all, at the beginning, we learn about the C programming. We learn about the fundamentals, and then we saw the applications where C programming or C language is used. Then we saw C, like it is used in effectively in various specific domains, like what is C programming and where it is used, like its formatting and its efficiency and portability. Then we learn some CS fundamentals, computer science fundamentals like number systems, decimal, octal numbers, hexadecimal numbers, and binary numbers. Then we learned about the data representation, bit, byte, and word. What is the difference between it, and how to use it in C programming. Then we saw the integrated number, positive and negative numbers, the basics, like very basics that we require to learn in programming languages. And then we also learn about the data types, like what are the different data types are there, like int, char, float, what are they, how are they used, how the memory is being stored there, and when we use in which scenario we use particular data types and all, and how many types of data types are there in various programming languages. And then we also studied about the conditional constructs, like various conditionals, like if, when to use if else, and if else, and also switch case, and when to use particularly which from both. And then we saw the iteration statements like do, for loop, or do while, and where to implement in C programming particularly. And then we saw the conditional, continue, break statements, where to use them. Then after learning the C, clearing our basics with C, we learn about the embedded C programming language, in which the operators, how it operates with regard to various operands, and how it returns a value. We learn that. Then we learn a collection, array, where what is array, like it is a collection of data of some data type, and address a sequential where it has indexes starting from 0, like that. And then we learn about pointers. What is a pointer? Like it's a parameter passing mechanism in function, so how to use it by passing the reference value. Then we learned about the strings. What is a string, where to use it, like it's a continuous sequence of characters, similar to array, that stores ASCII and its extension, ASCII value and its extension. Then we learned about the storage class, auto, register, static, local, static, global, and extern. Now coming on to the IoT part of our internship. First of all, we learn the very basic structure of the IoT, like what is IoT, where it is being used, and how it is implemented in industry projects. Like, so basically IoT refers to the network of physical devices, vehicles, buildings, and other objects that are embedded with sensors, software, and network connectivity, enabling them to connect and exchange the data. So this is what we learn, the basics of IoT. The data collected by IoT devices can be analyzed and used to provide insights. So like by using the data through IoT devices, we can analyze the data through using various tools and techniques that are available in industry. Then we saw then we it can also use to improve the efficiency, safety, and productivity across a wide range of industry. So through this we learned how IoT is being utilized in various industries, and how it is being properly used through various techniques that are available today. And then we saw the IoT, like it's rapidly growing field today, with integration with cloud, and yet artificial intelligence and machine learning. Like there are number of connected devices is expected to continue to increase in the coming years. So IoT is evergreen field. It's going to increase, and through IoT, various other established fields like cybersecurity, artificial intelligence, and cloud computing, they are all are connected with each other. So all will grow in the future. We learn about that. So then the very important part of IoT, like its architecture, IoT architecture, we learn about it. Like there are like various layers in IoT architecture, like sensing layer, network layer, data pre-processing layer, and application layer. So in the sensing layer, there are physical objects are present like sensors and actuators. So these objects, we use these objects to gather the data. So they are also termed as data gathering objects. Then coming to the networking layer consists of internet gateways, network technologies. So these are the data acquisition system where data is get acquired, or we can say data get transformed. So it's also known as data transmission. Now coming to the data pre-processing layer. So in the under the data pre-processing layer, a processing unit is there, like we analyze the data as I talked earlier. So data analytics or the decision making is enabled under the data pre-processing layer. So we also it is also called as process information. And at the end, the application layer, where smart application and management is done, like we integrate an application with our IoT devices. So various data we can see various data on our dashboard of the application. So it's a smart application. Now coming to the challenges of IoT. So there are various challenges of IoT, particularly as we know, there every technology has its advantages and disadvantages. Rather saying disadvantages, there are some challenges. So in IoT there are some challenges. So I will explain all the challenges briefly. So first of all, it's security. So it is said that it has a lack of encryption and insufficient testing and updating. So any hacker can use a brute force approach to hack the packets packets of the devices that we use, and it has a risk of default passwords. As we know, when we connect any two devices, like when we connect any application, it has some default passwords. So the hacker can try to hack the devices easily, and so the security is one of the challenge. And then the design. Before design, I would like to talk about the scalability. So in under the scalability, it refers that to the ability of a system to handle increasing workloads or number of users without a significant decline in the performance. So what does it mean? So under the scalability, we have data management, network capacity. So under the data management, the effectively managing and storing a large amount of data generated by IoT device. So it comes under the scalability challenge. And then there is also device management challenge, where the efficiently managing the growing number of IoT devices and ensuring that they can be easily configured and maintained. And then the reliability challenge is also there. So under the reliability, but first of all, we need to know what is reliability under the challenges of IoT. So reliability refers to like the ability of a system to perform the intended function consistently and without failure, like over the time. It is measured over the time. And so in the context of IoT, reliability is like critical concern, as the failure of even a single IoT device can have significant consequences. So some of the reliability challenges in IoT includes like device failure, network connectivity, and data accuracy. So now moving on to your next slide. So after that, learning IoT, where it is used, how to use, what is under IoT, and various challenges, we learn about the embedded systems. So like in embedded systems, like any combination of hardware and software which is intended to do a specific task, it can be called as embedded system. So for example, talking about embedded system example, we can say like our washing machine can be an example of an embedded system, because it is designed to work or to execute a specific task. So it comes under the embedded system categories. Then the categories in like standalone, real-time, networked, mobile. And the challenges in embedded system, like its efficient input output, it is one of challenge. And then embedding an operating system, code optimization, testing, and debugging. Now let's talk about the microcontroller that we studied. So an integrated service, or IC, which is capable of being programmed to perform specific tasks, is what is called as a microcontroller. So all components in single chip, less flexible, less design complexity. That's why we use microcontroller. Now the things to be noted when choosing a microcontroller, so there are some particular parameters that we need to know before choosing the our microcontroller for our application, like the application performance, microcontroller price, availability of the tools, and special capabilities. Then we learn about the microprocessor. So like, what is microprocessor? A microprocessor is a computer processor wherein the data processing logic and control is included on a single integrated circuit, or a small number of integrated circuits. Then all separate components, like it is more flexible, it has more design complexity. Then we learn about the installation of various software like LED. For installation like of the software and LED blinking, we have installed following softwares, like we'll install Pixim Lab and Arduino IDE. So for the interfaces of LEDs introduction, the simplest device used in most of the embedded system application and feedback work just like diodes. So if anyone who wants to learn how embedded system or its project is implemented, first of all we start from LEDs interfacing. So that's why we learn first in that. Then we learn about the LED basic programming demo, so in which we used basic LED program, toggling LEDs connected to a port of Arduino, build a hex file in Arduino IDE software. Then we load that hex file into our Pixim Lab software. Then coming on to our Pixim Lab. So Pixim Lab is a real-time emulator of development boards with MPLABX AVR GDB debugger integrated. So it is integrated with that. Then IC Sim Lab supports microcontrollers from Pixim, Simever, UC Sim, Quim, and all. Then Pixim Lab has also integration with MPLABX Arduino IDE for programming the microcontrollers boards. The purpose of Pixim Lab is to emulate real-time hardware, as it does not have any source code editing support. So for code editing and debugging, the same tool used for a real board should be used with Pixim Lab, such as MPLABX, Arduino IDE, or VS Code with platform in IO. Then we learn about the CLCD. So it's what is CLCD? Basically, it's a character liquid crystal display. It has two types of display. There are 16:2 and 16:4 types of display. So it used display all ASCII character and symbol. It has totally 16 interfacing lines. Then from D0 to D7 there are data transfer lines, and the controller can execute the instructions and data. So the RS line is for like register select line. The RS value is like 1 for data and the RS value is 0 for instruction. Then talking about the data processing in CLCD, like data processed by two methods. First of all is the delay method or Paul D7 method. So in Paul D7 method, so what we want to continuously monitor. So D7 is in data lines, we are providing data. So for read write, when the read is 1, it is read, or when on the read or write equals 0, it's write. So in read write pin is permanently grounded, that means only write, and so it only writes the data. So in CLCD from D0 to D7, that is from data 0 to data 7, they are connected to port D, and RS and enable pin are connected to port E. So for 8-bit it is connected to from D0 to D7, and for 4-bit it is connected to from D4 to D7. And for the enable pin act as an indicator by apprising LCD about the inception of the data transmission by the microcontroller. Now talking about the PWM, what is PWM? So sometimes it's also referred as PDM, pulse duration modulation. So it's the technique used to vary the active time versus inactive time in a fixed period. So mostly used to control the average voltage of the load connected, and it's used in wide applications like motor controls, lamp, dimmers, or audio, power controls, and many more. Then we also learn about the Blink app. What is a Blink app? So Blink is an IoT platform for iOS and Android smartphone that used to control Arduino, Raspberry Pi, and Node MCU via the internet. Blink was designed for the IoT. It can control hardware remotely. It can display sensor data. It can store data, visualize it, and do many other cool things. So like blink app, so it allows the users to create amazing interfaces for their projects, like using various widgets which are provided. So like there is a blink server. So blink server is responsible for all the communication between the smartphone and the hardware. Then we can use blink cloud or run like our private blink server locally. So it's an open source cloud, easily handles thousands of devices and can even be launched on a Raspberry Pi. Then talking about the blink libraries, so they enable communication for all the popular hardware platforms with the server and process all the incoming and outgoing commands. So from here onwards, Shubham, my group mate, will explain further project, and he will also show you the demo. Thank you.
Thank you, Jayesh, for the overview of the interview, for given the overview of the internship. Now I am Shubham. I will be talk about the practical concepts related to the internship. Now first one is garden light control. Here I have used LED lights and LDR sensor. So now let us talk about what is LED. So LED is a light emitting diode and it is a widely used standard source of light in electrical equipment. It has a wide range of applications ranging from your mobile phone to large advertising billboards. They mostly find applications in devices that show the time and display different types of data. So LED is nothing but semiconductor device that emits light when an electric current flows through it. When current passes through an LED, the electrons recombine with holes emitting light in the process. LEDs allow the current to flow in the forward direction and blocks the current in the reverse direction. Light emitting diodes are heavily doped PN junctions, and based on the semiconductor material used, the amount of doping, LED will emit colored light at particular spectrum wavelength when forward biased. The LED is encapsulated with a transparent cover so that emitted light can come out. The LED symbol is a standard symbol for a diode with an addition of two small arrows denoting the emission of light. The simple LED circuit consists of an LED and voltage supply and resistor to regulate the current and voltage. So now how does the LED work? When a diode is in forward bias, the minority electrons are sent from P channel to N channel, while the minority holes are sent from N channel to P channel. At the junction boundary, the concentration of minority carrier increases, so the LED will be blinking. The excess of minority carrier at the junction recombine with majority charge carriers. The energy is released in the form of photons on recombination. In standard diodes, the energy is released in the form of heat, but in light emitting diodes, the energy is released in the form of photons. So we call this phenomenon electromagnetism. So it is an optical phenomenon and electrical phenomenon where a material emits light in response to an electric current passes through it. As the forward voltage increases, intensity of light increases and reaches maximum. Now I will talk about LDR sensor. So what is LDR? LDR is nothing but light emitting resistor. So most home applications, outdoor lighting and street lights are normally operated and maintained manually. This is not only dangerous, but it also wastes energy due to staff negligence or unforeseeable events when turning this electrical equipment on and off. Therefore, by using a light sensor, we can automatically shut off the loads based on the intensity of the daylight. It actually sensing the radiant energy present in a relatively small range of frequencies, often referred to as light, which runs in frequency from infrared to visible up to ultraviolet. A light sensor produces an output signal that indicates the intensity of light. The light sensor is a passive component that produces an electric signal from this light energy, whether it is in visible or infrared portions of the spectrum, because they transform light energy into electricity. Light sensors are more generally referred to as photoelectric devices or photosensors. So LDR is also referred to as a photoresistor, photocell or photoconductor. LDR resistance value range from many mega ohms in complete darkness to only a few hundred ohms in strong light. As a result, these resistors are widely used in a variety of applications due to this variation in resistance. The wavelength of the incident light affects the LDR sensitivity as well. Now serial tank interface. So basically this interface is used for to show the water level of the water level in the tank. Here it will read the volume of the water in the tank through serial communication, means it uses SPA protocol, serial peripheral interface, and display it on CLCD, which was the 16:2 LCD. It controls the volume of the water in the tank by controlling the inlet and outlet value by sending the commands through serial communication, and it will display the volume of the water in the tank on the CLCD. So here our this one is the requirement for the our project. The description is I will now describe this process. Here input is required serial tank process reading the volume of the water in the tank by sending the commands to serial communication, and output we get is display the volume of the water on gauge widget. Then the requirement number our 7 is inlet valve control. Here we require 2 button widget on the blink IOT app, and the process is to detect the change in the logic level. And what we get from this, if the button widget is logic high, then turn on the inlet valve by sending command through the serial communication, and if the button widget is logic low, then turn off the inlet valve. Now coming to the output valve. So here also input is button widget in the blink app, and process is to detect the change in the logic level. Output is button is low, turn off the outlet, and by sending command. If button is high, turn on the output valve. So now this is a home automation project simulation block diagram. Here Arduino is used for as a microprocessor or microcontroller for our system, and here blink cloud is used for sending the LDR sensor data. All the commands are stored in this, and mobile app will used for controlling the some devices like motor or any and water level, or it will also display the notification of the user of the system. And main thing is home. So this will be the interface of our project. Here I connected the LEDs which was controlled by LDR sensor. According to the LDR sensor input, LED will be blinking on or turn on or off. Then the Ethernet is used for to connect the Arduino with the blink app through wirelessly. Ethernet is used here. There are total 3-4 pins are used for, and it uses SPA protocol. So MISO, MOSI, reset pin, then clock pin, then clock source pin is used here. And for LED, pin number 3 is turning on. By using the input of LDR sensor, LED will be turned on. And now the second part of the project is here. I have used a CLCD for displaying the all the inputs get by the volume tank and the LDR sensor and the temperature of the room which was present in the home. And the last part is will be the our heater or cooler. So this is the serial remote tank interface, and final one is a blink app interface. First diagram is showing us the blink dashboard which is used for show the devices present here. So I have name given as home automation system. Then second one is a interface of tab 1, means here the cooler interface, then heater interface, and the temperature of the heater it will display, and the notification also it will display. And the last one is home automation system tab 2 system. For this this is used for inlet and outlet valve button to turn on or off the system, and it will display the volume of the water. Now I will show the demo of our project. Now I will show the demo of our project. Here to show the demo, first of all I have to open the software which is named as Fixim Lab. Here first of all we have to select board as Arduino Uno board. Then we have to load our hex file which was generated by Arduino IDE software. I have included the file here. Then go to the modules and open the spare parts. Here the output are the we can say interface of our hardware or block diagrams here are shown. So see, first one I will first I will show the interface of LED with LDR or control the LEDs with the LDR sensor. LDR sensor is nothing but light emitting resistor, and it will capture the sunlight rays, and so it will give as a input and show displays the output as is in the form of the in the LED. So LDR will be the read the sensor value. Based on the reading from LDR, it will vary the brightness of LED, which resembles the controlling garden lights based on the availability of sunlight. We have to connect Arduino Uno with through LDR sensor and lights of the LED. So this is a requirement first of our system, and it will known as a garden light control. Here input is LDR sensor, and process is to read the LDR sensor value. Based on reading the from LDR, vary the brightness of the LED, which resembles the controlling garden light based on the availability of sunlight. So see, if sunlight is reducing, LED will be blinking, and if sunlight is goes down, if sunlight is goes high, so LED will be goes turn off. Now our second system is nothing but temperature control system. This will be the temperature control system. Here I have connected heater and cooler for displaying the means temperature or temperature. The temperature control system consists of heating resistor, LM35 temperature sensor, and a cooler, which enables the temperature control system at home. It will read the temperature from the temperature sensor, which is known as LM35, and it will be display and see LCD. See here at the T value, it will display the room temperature around 27 degrees Celsius, and control the temperature of the system by turning on and off the heater and cooler through the Blink IoT mobile app. Now I will interface the Blink mobile IoT app. So 1 minute, I will connect this through my mobile. This wireless connection is required. I will scan through it to my mobile. So the mobile is connected. Now I will show the Blink, open the Blink IoT. So see, this is the dashboard for the Blink software, where I was created some devices inside this. Inside this I was done the two tabs. For first tab it is for temperature system, and for tab 2 it is for the inlet tank or outlet tank control system. Now see, both cooler and heater are turned off. If I turning on the heater, see the temperature is increasing up to the 35 degrees Celsius. When temperature is means maximum or up to the 35 degrees Celsius, it will say the notification that the temperature is above 35 degrees Celsius, and automatically it will turn off the heater, and it will also sending our notification that turning of the heater temperature is above 35 degrees Celsius. And if we on the cooler, then it will reduces the temperature of our whole room. Like this temperature system is working. see the motor is here, cooler is on. If we off the cooler, uh, it will display cooler off from on the CLCD, and see the status of the cooler is turning off. Now I will go to the second system, which is a serial remote tank, and here for this tab 2 is required. Here outlet in inlet valve and outlet valve and volume of the tank is displayed on the blink app. If I turn on the outlet valve, then volume of the tank is uh, opening, so volume of the tank is rising here. Now let us take out 1000, up to 3000 it will take. So once it's completely filled, it will stop. So see this it will automatically stops the outlet valve, and here we get the notification that turning of the heater, so that tank is full, turning of the inlet valve. Now if we turning on the inlet valve, see water is decreasing. Here we are setting threshold value of the volume as 200 2000 ml 2000 liters. Up to that, the all the inlet and outlet valve will be stopped. Like this our project will be working. And see here we get the notification that the turning of the inlet valve, water in the tank is less than the 2000 ml 2000 liters. So I was all done with my practice, my demo. Here I was also shown the heater cooler, then CLCD and LED control system, and this is the the system is nothing but the Ethernet is used for the communicating the Arduino with the Blink app. So this is our project. So thank you very much.